Hi everyone. So I'm back with another video now in the clustering series. In my previous videos on clustering, I have actually shared a couple of templates in Google Sheets, and another was a Python code implementation. So in this particular instance, I'm going to be showing how to do cluster analysis. In fact, specifically k-means clustering, which k-means is a very powerful clustering algorithm, and I'm going to be using good old Excel. All right. So this is a 2019 version of Excel, and this has got certain capabilities. For instance, it can run something called a Power Query. Okay, so that's going to be useful here. We're going to use Power Query. We're going to use simple other stuff like basic formula like VLOOKUPs. So let's get started. Um, so this is the data set. Okay, so the observation is essentially a product. So in our case, we are trying to do a product segmentation. So here we have got 150 products. Okay, and my recommendation is that for this to really work well, you actually need quite a significant number of products. So anything under 100 um, is not very recommended. It's good to actually have a lot of products so that you can understand it properly, the impact of this. And then for each of the products, we are taking certain metrics. So just to talk a little bit about product segmentation here, product segmentation can obviously be done in multiple ways, and you can take different kinds of things. So there can be multiple ways of doing product segmentation. You can look at the clicks, impressions. You can look at ROAS, and you can also look at the total number of sales coming from the product. So in this case, what I've done is taken very base or basic metrics, which will not get affected by the amount you spend, for instance, on every product. So that is going to be a variable, and I think that's not a good idea. And therefore, I have taken things which are independent of the amount of exposure a certain product has got. So this way, you will be able to get a very intuitive idea about the potential of that product. So the metrics that I've gone for in order to do segmentation, and again, you can use n number of there can be n number of ways of segmenting products. All right, there are obviously some popular ones which do the rounds all the time in the online space, that you can actually do clustering in many ways. For products, for instance, you can do it for customers as well. You can do it for different other things. But in this case, we are looking at product segmentation, and we're using ROAS, which is the return on ad spend, the CPC, CTR, and price index. So CPC, CTR are obvious, cost per click and click-through rate, and price index is essentially a simple index which is calculated like this. You take one as you give the average price of the products that you're talking about. So 150 products here. The average of all these products is going to be considered as one, and then there's a markup either above or below, depending on the percentage variation from that average. Okay, so for instance, if it is 0.6, so it means that it's 0.6 times, that is 60% of the average of the average price of all the products. Okay, so 1.5 means it's 1.5x of the average price. So that's a simple thing. So this is to understand how the pricing is also impacting. All right, so and instead of just giving directly the price, we are actually taking the index just to understand the relative impact of pricing. Great. So that is how we are. The metric is, the metric collection is this. These are the four variables that we're going to look at in order to understand the impact of clustering. In machine learning parlance, this is therefore a classification problem. Interestingly, this very data set can actually be used also for regression. Okay, and regression analysis. And regression analysis means to understand the impact of one or more variables on another variable, and that relationship, not in terms of classification, but in terms of how actually changing these variables will impact the outcome variable. So, for instance, we could have had ROAS as the outcome variable, and we could have had CPC, CTR, and price index as our input variables, or the features, so to speak, and this could have been our outcome variable. But nonetheless, this is the classification approach that we are trying to do. We are trying to cluster the products so that we can take decisions accordingly. So how do we take decisions on the basis of this? We can obviously segment our products in our campaigns differently. We can have different kinds of marketing initiatives. Our ad copies can be different, or pricing and our budgeting can be different, right? We can spend different kinds of different amounts of money depending on the potential of the product. So if we see that the product is really high potential, then we go ahead and check whether we are actually spending enough on the product or not, and then we can, you know, decide whether or not to give a boost to the spending for that particular product. So and obviously similar types of products can be clubbed together as well. All right. So we usually go with high margin and low margin, high ROAS, low ROAS, but these are just one single aspect, right? There are so many aspects of the product. CPC and CTR, for instance, are also different aspects of the product performance, because the CPC shows how much the product is actually worth in the market. If it's a very high demand product, then it naturally will have a higher cost per click. Then you wouldn't really want to classify it together with products which actually have lower cost per clicks. All right, because that's not something probably that you can control a lot. It's just high demand, and therefore the CPC is going to be higher for that particular product, the type of product. So these things are very important. And I think obviously the product category, those obviously can be useful ways of segmenting a product. But just imagine this as an exercise within a similar sort of product category, but can you have a similar broad sort of category, but there are certain different types within that, and for that you can actually use this sort of an approach to look at click-through rate. With click-through rate can also be a very interesting thing. I mean, it can depend on whether or not at all the product is getting enough click-throughs. It's getting impressions, but whether or not people are actually clicking through the product, and therefore that can also be a good indicator of, or at least can be a good way to classify. Okay, so without talking further about that, let's now look at how we are going to do the segmentation. So we have 150 rows of products, like I said, and then we're going to do something called a random cluster choice. So the way K-means works is that you first have to decide the number of clusters. You have to tell the algorithm how many clusters would be there, and in this case we are going to go ahead with 3 clusters. All right. So we are going to randomly choose those first, those clusters, and then we're going to do iterations and then find out the actual clusters. So this is nothing but a random function in Excel. So ceiling is something like floor. It just rounds off the values, and then you have the actual random function within that. All right. So this is called nesting of function. So random, and then you are applying it to H41. So let us see what is there. So this is it. So essentially what you're saying is that between 150 and 1, choose any integral number. All right. So that's what it's saying, and then it's coming up with 86. The interesting thing here is, which is also a little bit annoying, is if I do any changes to this sheet here, as you can see, the numbers are going to change because it's random, right? So so you wouldn't want to do that, right? You need to fix the specific points as clusters, which you are choosing at the onset. So in order to do that, even if they are random, you need to fix that so that going forward it doesn't change every time you just do any changes on the sheet. I mean, that's going to be ridiculous, right? So what you need to do, therefore, these are the points, as you can see. These were the ones that were initially chosen. After that, the sheet has probably been refreshed quite a few times. So you just need to copy and paste them here. That's it. And then you have to copy paste them as values so that the formula part goes out, and therefore this is not variable anymore. So every time the sheet refreshes, this doesn't change. So what is happening here? Let me just again explain what's going on. So we are trying to choose centroids or central points, and these are basically the points around which the rest of the points will be clustered around. Okay, so these are our initial estimates of what are the central points of each of the clusters, and this of course will not be not necessarily be a very good estimate, but sometimes you can just do averages on the numbers and sometimes come up with this number. I'll talk about towards the about this towards the end of the video, how this can actually be a non-trivial problem. This can be quite a challenging thing to actually come up with that initial number of clusters and to also find out which clusters to assign initially. However, it's really the choice of the number of clusters which is more complex and more important, because this actually will through iteration become better, the actual points which have been assigned as clusters. So now let us actually look into what we are doing here. So we have got the observations, And now then we just need to look into the data set. All right. So 44 has got 5, 3.5, 1.6, and 0.6 as the values of these metrics. So as you can see, those are the values here. Similarly for 2 and 3, we've got those. So we have got the initial observations which have been chosen as clusters. All right. Initial 3 ones. Now starts our first iteration. We have to update it, right? Now we have to choose which points, we have to look at all the points, and we have to see that that the points are basically the close, always assigned to the nearest cluster. That is what k-means is trying to do all the time. All right. So this means that you have to rearrange it, right? So some points will be shifted to the cluster which is nearest to it. So how do you decide, or how do you calculate um, you know this concept of nearest cluster? You obviously measure distance, right? And the measurement of distance is like a good old Pythagoras theorem or Pythagorean theorem, where you just and in our case we call it the Euclidean distance. So the distance between any 2 points is simply given by the root over of x1 minus x2 whole square plus y1 minus y2 whole square. All right. So that's the simple formula for it. Some other day I will explain that formula if anyone requires it. But that is the formula that has actually been used here. So what we're trying to do is, for each of the clusters, we are the central cluster points, mean cluster points, we are trying to measure the distance between the cluster and the specific point. All right. So as you can see, so this is going to come at last. So we are looking at observation 1. So all the 150 observations are here. And for that, first we are trying to measure that specific distance that I just talked about. So we have 4 of these, right? So, 4 metrics, ROAS, CPC, CTR, and price index. So we have to measure the distance of the point with respect to 4 dimensions. And that's why you'll see that in our VLOOKUP formula. So why are we doing so? First of all, let's break it down. This looks really big, but it's actually not very big. It's just tedious, but it's not very. It's big, but it's not very complicated. So what's really happening here is, if you look at the first one, I'll just explain one, and then we'll understand the other ones. So VLOOKUP of K14. So that is nothing but. Let's just look at it. Yeah. So you are just trying to find out, first you're trying to find out the point, all right, the actual data point from the actual data set. So this is observation 1. So K14 is looking at, this formula is looking at trying to find out K14 from A2 to E151. So that is A2 to E151. All right, there you go. This is E151. So it's trying to find out this particular point from the original data set. Okay, and so obviously it is looking at ROAS first. So that's why it's the second column. Okay, so that's how VLOOKUP works. So it's looking at the second column. It's trying to find out the ROAS for this particular observation. Okay, and then it is subtracting it. So for each dimension, you have to subtract it, right? The value of that dimension, you have to subtract it from the corresponding dimension of the centroid or the cluster in order to find the distance from the cluster. So if I look at the next part of it, so VLOOKUP of 1, so obviously you're looking at first cluster, and then you are looking at this particular table. Okay, so that's where it starts from. As you can see here, J4 to 06. This is J4 and this is 06. So you're looking at this particular table and you're trying to find out ROAS from it. So that's why I've given 3, because ROAS is in the third column, right? So that's how it works. And let me just do one thing. Let me just quickly show you, what is basically the formula. And I think, that would be clearer to you. So the Euclidean distance is calculated. So there you go. This is a very neat way. So in 3 dimensions, distance between 2 points is root over of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. In our case, there will be actually 4 points, right? So you start with something, so you can have a, b, c, d. So you can have a1 minus a2 square, a2 square, yeah, plus b1 minus b2 whole square plus c1 minus c2 whole square plus d1 minus d2 whole square. Okay, so I hope that explains it. So that's how you calculate the cluster distances, and it calculated for each observation, like you can see. So you obviously have 3 clusters, and then you are calculating the distances from each cluster, and then you try to find out the minimum of the distances, right? And the minimum distance, the the cluster from which the point is nearest, that is the distance is minimum, is going to be the cluster where it is going to be assigned. Okay, so you can, as you can see here, so it's trying to find the minimum distance, minimum of these values basically. Okay, so that's what it's trying to do, and once that has been done, you will get the entire list of the entire column will consist of the cluster assignments for each of these points, for each of the observations. So once that is done, then you will create your iteration to clusters table. Okay, so these this basically shows that the cluster assignments have changed now. Okay, now how do you do that? So this is basically done using averages. All right, so I'll just jump into this particular sheet now, and I will show you how this has been calculated. So you have 150 observations, but as you can see here, you will have different observations being assigned to different clusters, right? So for instance, if I just filter this and only look at the points which have been assigned to cluster 1, then you will see that for these different points, you will have different rows values, right? So what I'm looking at here is the second column of the original data set, as you can see here. So I have copy pasted, as you can see, the original data set here, and from here what I'm trying to do is finding out the the ROAS value for each of the observations which have been assigned to cluster 1. Okay, so this is just one example. I'm just showing it for ROAS, and you will see that what I have done then is I've taken the average of all of these. Okay, so all of these data points I've taken the average of here, and this then has been actually put into this particular table. Okay, so that's it, and you just do that same thing. So for all the points which have been assigned the first cluster in the first iteration, you just take the new dimensions for each of these clusters. Okay, and you just repeat the process for 2 and 3. So now what you have is a different set of clusters. Okay, so your initial 3 clusters have now been moved. Why? Because you have had your points reassigned to different clusters, right? And then you have to relook at the thing from the start, right? You have to find out the clusters which actually have all the points should be to the nearest cluster, and as long as that's not happening, you have to keep reassigning your clusters. All right, so you're looking at again this observation, for instance, which is 1, so this is 14, and then you're obviously referencing it in the main table, and then you're doing a VLOOKUP over this particular table for the different cluster dimensions. Okay, so the table has changed from this to this, otherwise the formula remains exactly the same. Okay, so you can just copy it over and just just make those small little changes, and then drag down the formula. So once again, so you have the second iteration now. So so what's really happening here now? Based on the new cluster positions, you have the points reassigned again to different clusters. So you will see that in some cases, so for instance, in terms of the cluster points, you will see that they had also changed in the first iteration, right? After the first iteration, you see the rows had changed, the CPC had changed, the CTR had also changed. Okay, for the first cluster, and there were some changes for the other clusters as well. So not very big, but they will change only by small amounts every time. So that's how this process works. Similarly, in terms of the points which have been assigned, for instance, there you can see 19 was at the observation number 19 was assigned a cluster of 3 previously, and now observation number 19 has been moved to 1. So there won't be too many changes, but these changes happen whenever they're sort of outliers, meaning that whenever after any kind of assignments, reassignments, either of clusters or of points, you find that there's still a point which is actually which should be, or which is actually nearer to another cluster, then it gets reassigned to that particular cluster. So that's how this basically works. So this again is done on the third time, right? So I'm not going into this explanation again. So you find after the points have been reassigned to the clusters, then you have to recheck the clusters, right? So you have to check the clusters, and then you have to see if the clusters are changing. So again, they have changed a little bit from last time, as you can see. All right. So it's an iterative process. So this keeps changing. So once that has changed, then you also have to look at the different points. Okay, so you have to look at you have to measure again the cluster distances from each point. And once that is done, you do that again for the fourth iteration process. Okay, so you just continue doing it. This is, by the way, the problem with Excel. This is something that I had mentioned in my associated LinkedIn post, that there's actually going to be a certain drawback that I'm going to talk about when you're trying to do k-means clustering using Excel. So this is an iteration, as you see, and there is actually no um, there's no fixed end to it, so it can end anywhere, depending on at what point. You just don't need to do any kind of reassignment of any of the points anymore. I mean, all the points are satisfactorily uh, placed within the clusters from where the minimum distance criteria has been met. Once that has happened, you can stop, but till that point you have to keep doing these iterations. So this is actually something that you should be doing through programming. You can do this through different kinds of programming languages, but Python and R, these are usually the programming languages that can really do it very, very fast. So I've already shown through Python how can k-means clustering be carried out. But I just wanted to show through Excel that it's actually possible. Conceptually, this is possible to do so in Excel. It's just that it's going to be much, much more tedious, and you have to be, you just have to keep going at it. So now I'm going to show how you can at least do one part of it much faster, and that is basically this particular table that you're calculating, where you are recalculating your cluster positions. This is something that you can do with something called Power Query, and I'm just going to show you now. So this fifth cluster table, as you can see here, that's already created, but this is actually being created to Power Query. I'm just going to show you how this has been done. So what you need to do is, as I said, first of all, you have to start with a more recent version of Excel. So if it's older than 2013, for instance, you won't be getting access to Power Query. So Power Query is available under the Data tab, okay? And this is that section where it says Get and Transform Data, Queries and Connections. These are the sections where Power Query functionalities exist. So all I need to do is click on this iteration table. So because the cluster reassignment table is based on the previous observation or point reassignment table, so I'm just clicking on this table, and then I'm going to click on this particular table of range. Okay, so this is a new query linked to that Excel table. So this is actually going to make our work easier, as I will show, and just give it a minute to load. So there you go. Now you will see that this particular table is showing up here, and there's actually a query here, as you can see. So it's kind of like you can say something some sort of programming language that's going on behind the scenes, and which is actually doing this querying part. So this particular table has been created, but before actually I move on, you can actually see that these exclamation marks have come, and these means these typically mean that there's something wrong and it's not going to work. And what I'll do is I'll just show you that it's not going to work. So what I'm doing first is that I don't need these cluster distance columns from the iteration 4 table. Okay, so what I only need is the cluster assignment and the observation columns. So I'm just deleting these. I'm just selecting them, and then I'm just removing these columns. Okay. Now what I want to do is merge this with the original dataset table. Okay. Now remember, the original dataset table. This is exactly what we actually did when we were doing it manually in Excel. We were trying to do a VLOOKUP between the individual points and the clusters, and so obviously these two particular tables were being merged. So that's what we're trying to do here. So we go to merge queries here, and we click there, and you will see that when I actually try to do this, just load it up. Yeah. So here it says that you have to select two tables. So this is your existing table, right? The iteration 4 table, and then you have to select another table from here, which is going to be the original dataset table. Problem is that it's not appearing here, and that's because the table name is wrong right now. Okay, so I've actually made some changes to this. I copied over another practice data set that I was using, and that's why that the names of the columns have been changed since, and that's why the table name has also changed. I mean, I've also changed the table name. So when I actually click on this, you will see that we can find an Excel table name iris underscore data. So what I want to do now is, you can see this is this particular query. So I want to go to this error, okay, and I want to resolve it because I need to use this particular table for the merging purpose. Otherwise, I won't be able to proceed to the next step. So I click on go to error, and then it gives me this particular query. Okay, so all I need to do now is within this particular name section, I just need to update the product, the table name, and the table name I know is product table. Okay, and once I do that and click on this tick one here, just a second. I think I've actually forgotten the name of the table. Let me just jump to the data set again, the original data set. So if I go to table design, this is product underscore data, right? So let me just do this from scratch again. I go to data, I go to table range, get part query up, and then I'm going to just change the name of this table. Okay, so it's going to be product underscore data. I was actually doing it right the first time around. Okay. Okay, so right, so the table name is not just the only one which has a problem. It's also the column names. So the column names have to change as well. So since I actually use my data into an existing template that I've been using, so that's why the column names have to be changed, because I've used different column names now. So the column names are rows, they are CPC, CTR, and price index. So I've got the, yeah, great. So I've got all the naming convention right. I mean, you have to ensure that it's always capitalized or decapitalized in the right way. So now I can jump to this iteration table, and now I can do my merging. All right, I don't need that query anymore. So what I need to do is I just need to select these columns and just get rid of them, just like last time. I don't need them, and then I can do the merging with the original data set. Okay. In fact, before I do the merging, I'll just change the name of the table, just for your understanding. This will be confusing. I can just click on it. I can rename it. So I'm just working within Power Query, right? So this might be for a lot of you a new thing, right? But it's pretty cool. You can actually do many smart things with this. Anyway, so let me just merge queries now, and then you'll see that it's going to appear here, right? So it's product underscore data. This is the original data set, and I'm merging my data situation table with it in order to get the next cluster reassignment table. And then I do an inner join with it, right? Okay, and I have to select. So what's an inner join? An inner join is simply a join for only the matching rows, and you obviously have to have a common column, and you have to choose the common column, which in this case is the observation one. So once you do that, you'll see the OK button is activated. So 150 of 150 rows have been matched from the two tables, and then you click on OK. Then something interesting happens. Then you have the product data, as you can see here, listed in the form of a table. Okay, and then you can actually expand it, and then you can choose which of the columns to show and in what format. So I don't need the original column names as prefix, and I also don't need the observation because you already have the observation for it, right? That's common column. So I need the other ones, the row, CPC, CDR, and the price index, the dimensions I need required here. Okay, so this is what we were looking for, right? So once we have this, now what we have to do is we have to calculate the average. Remember, in order to get to the last step, the average of, for each of these observations, we need to calculate the average of each of these dimensions. And that's what will give us our reassign clusters, the new clusters. So what we do is we actually click on cluster assignment and then we do group by. Okay, so group by is essentially a way of doing precisely that. So cluster assignment is what we group by, and then we create some new columns. So one are called rows, called CPC, CDR, and then price index. Okay, and then the operation is the average. So we are just doing the average of these different metrics, and we are going to choose the corresponding columns. Okay, so these are the new names, by the way. I could have given them, say, reverse average or something, and this is going to be CTR, and this is going to be price index. Great. So so what do you expect will happen? This will actually give us the final version of our table. So there you go. This is the final version of the table. All right. So we click on close and load 2, and then a small window is going to come up, and we're going to choose the existing worksheet from there. Select this section for instance, and then click on OK. So there you go. I mean, this is the fifth iteration cluster table. This is for this is the same as the one that's above. So this was already done. So just showed you the same process again, and then you just have to continue doing this. Okay, so you have to continue making the cluster tables, and once you have reassigned the clusters, then you also have to see if the points are actually closest to the clusters, and calculate the minimum distances, and then see the cluster realignment. So if they are getting reassigned to more clusters, then you have to do the next process again, which is to actually recalculate the clusters from scratch. Because once the points get moved, then you also have to reassign the clusters, because the clusters have to be the average of the points, right? So that's basically the idea of it. And as you can see, conceptually speaking, it is possible to implement this in Excel, but it's extremely tedious, and we don't know when it's going to end, right? That's the most important thing. We don't even know that it's going to end at the 10th iteration. It's impossible because it's an algorithm. So the only way to do it is to do it programmatically. I have shown that through AppScript in Google Sheets. I've shown that through Python code in Google Colab in my previous discussions on k-means clustering. So in this instance, I've shown it through Excel. But yeah, I mean, you can definitely give this a shot. But the most important point is, the idea that you can actually do this for product segmentation. So product segmentation is, typically done, like I discussed at the start of the video, through, just one or two things at most, whether or not it has a high margin or a low margin, or whether it is actually, whether it is reached a certain threshold of ROAS, or is below or above that, or maybe it is a high serving or a zombie product. So these type of product segmentations are there, but you actually can cluster the products on the basis of multiple metrics, and that's going to be a powerful one, because then you are looking at it from multiple dimensions, and then you are and the segmentation therefore will be more robust and comprehensive. So that was basically the idea behind it. Now, just one last point before I actually finish this off. This process, like I said, can obviously be done programmatically in Python. One of the reasons why it is easier is obviously that you can do this iteration, and not just iteration using the concept of loops, but more importantly, you would remember at the start of the video I said that you have to tell the algorithm, you have to supply the number of clusters at the very start, and that is a problem. Obviously, how would you know, right, how many clusters you would require? Just looking at the data set is very difficult to understand, to visualize how many clusters are ideal. So what sometimes, what in fact most of the occasions people would do while using Python code, for instance, is use something called the script plot. All right, the script plot is actually something called it's also called the elbow plot. So this is how it really looks like. So it obviously talks about principal component analysis. I'll talk about that later on. But the script plot actually is useful for for K-means algorithm as well, K-means clustering. So the Elbow plot basically shows you what would be the ideal number of clusters. Okay, so for that I would actually have to explain the loss function, but typically it is that point after which there is no significant decrease in loss. Okay, so what that really means is beyond the scope of this discussion, that I partly discussed in my video on the Python code implementation of K-means clustering. So I would definitely ask you to look at that. So that basically gives you an idea of the number of clusters that you should be looking at, and therefore it makes your process easier. But even there, you actually have to start with a certain number of clusters. So you actually still have to provide a certain number of clusters, and then it iteratively sees using the tree plot where at what point your optimal. What is the optimal point beyond which it has no significant, that there is no significant impact on the reduction of loss by adding number of clusters. So that is your optimal number of clusters. But nonetheless, this is still a widely used, something that is widely used across the industry. K-means clustering. There are multiple other clustering algorithms. I'll be discussing them in the coming days. So by the way, I have largely been inspired also by the work by Dave Langer. So this is his GitHub. So it's only fair that I also give reference to his efforts. So without him, I probably would not have been able to make this video or come up with the detailed explanation. So I definitely ask you guys to also look into his work. He's a very senior guy, data scientist at Microsoft, I believe, and for many years, and now he's a data science coach. So definitely give his work thumbs up and a look. But yeah, this was the overall explanation. This is my version using the concept of product segmentation, and do let me know how you going to use it, and if this was useful to you. And definitely like and share and subscribe and spread the word about my work. Thank you.